Welcome, MardiGrass 2025. Thanks for having us. I'm Allison. This is my colleague and mate Jess. We've been working on plant tissue culture for about 10 years of various species. And for about the last 18 months, we've been working with Superbly Green and Cymra Life Sciences, tackling the challenges of cannabis. I'll be covering the lab section, and Jess will be covering the transition of the plants from the lab to the glasshouse, which is called Deflasking or Acclimatization. Would ask that if you've got any questions, you can hang on to them till the end, and we'll get to them. Now I'm nervous. Sorry. Okay. Plant tissue culture. It's a collection of techniques that directs plant cell growth at a focused output. It's usually done sterile, and for our purposes at Superbly Green, it's to replicate large numbers of cannabis plants, with the end point being plant house pipeline of disease-free, quality uniform plants. It's based on the theory of what's called cellular totipotency, which is that any cell has the potential to become any other cell. In practice, this is complete garbage, because to get a single cell to do exactly what you want it to do, you have to be pretty lucky or have a very well-developed protocol. It's like saying anyone can buy a house. Totipotency is pretty much a good mental model as an overview for the process, so that we can move on and look at more specific techniques. And in plant tissue culture, everything is a variable. The fresh air exchange, the kind of sugar you use, the lighting you give it, the CO2, what's that stuff called? Permeability. Come on, Leonard, you're in the audience. What's the word? The way the nutrients move through the mix and are uptaken into the plant. Because any plant placed in a tightly controlled environment will do pretty much exactly what it wants. I wish I knew who said that. And it's up to us to work out what the plant needs so that we can provide that clean pipeline of plants to the plant house. Variables are where you keep good notes. Variables are even better than having brilliant ideas, because what we do is a series of easy, discrete tasks that chain things together and form our protocol. You pick to test that process. If it doesn't work, we don't do it again. We move to the next thing. Brief history, I've been told this is a bit dry, but the first printed reference to any study using plant tissue culture for cannabis was pre-1987. I haven't seen the actual reference, but it only referred to callus, which is a kind of undifferentiated plant cell matter. It's almost like a tumour. It's blobby. It can be an endpoint, but it's a pain in the neck. It didn't look like they got viable plant material from it. And the second studies that came out soon after that, just prior to the legalisation of cannabis in America, were from Dr. Hemant Latta at the University of Mississippi. These were really difficult to replicate, and it turns out that all her lines were available because they were the only DEA licensed hemp facility in the US, and they didn't work on anything else. Because of the change in cannabis legal status, there was real and professional pressure for people to come up with definitive answers. Many of these answers were partial, and most didn't work for more than one or two sets of sample strains. There was a lot of plant media sold at the time that said anyone could do it if you use our kits, and most of that media was utter garbage. They did sell a lot of it, and a lot of us were trying to work out why it didn't work, until the publication in 2020 by Page, Montgomery and Jones on basal media optimization, which set out a wide range of different media that could be used, and none of which worked completely. But it did show us that the situation was more complex than we thought, because we thought cannabis would be easy. You take a cutting, you stick it in the ground, bit of rooting hormone, bit of sunshine, Bob's your uncle. And that hasn't been the case for cannabis plant tissue culture. It's not easy though, so why would you bother? Pathogen-free starting material for any large-scale commercial grow or even small-scale home grows, where legal, is of critical importance. New pathogens arrive every few years, such as hop latent viroid disease, that progressively attacks plants over time from the root zone up and affects yields. It's not just confined to hops and cannabis. There are lots of plants that are vectors for that aren't affected by the disease. It comes in on shoes, comes in on the air. And for grows that rely on consistent sites, HLVD is a disaster. The main reason at Superbly Green that we back up our stocks for cannabis plants and tissue culture is in case something happens. If we get another pathogen through, if we have a glasshouse failure, if we have a wild storm, if there's a delivery pipeline that fails, and we have an issue, we've always got stock that we can go back to, repopulate the glasshouse, again with disease-free clones. Tissue culture actually saves space. So we pursue a mixed strategy of mothers and tissue culture plants. But if you were just to rely on the mother plants themselves as whole ex vitro plants, we'd need a lot more space. Eventually we'll move to more of an emphasis on plant tissue culture babies for the backup genetics as well as the pipeline. The other reason to do tissue culture is to enhance conventional breeding strategies. So things like marker-assisted breeding, which is not GM, it's identifying loci on the chromosome that have a particular impact on a plant's growth. It could be pathogen resistance, it could be nutrient uptake or water stress. What's that word? Water stress tolerance, that's the one. Once you've identified those genes in a population of cannabis, you can test and breed those into the lines that you're currently working with, because it's not just pathogen resistance you want, it's the morphological stability that allows large-scale growth to take place so that you know what you can predict your workload, you can predict your harvest, you know what to expect from your plants. Here's why you wouldn't bother, because it's a lot of work and it makes you cry. Research is really frustrating, but it's great. It's absolutely inspiring when it works, and we're really lucky it's Superbly Green. The science is absolutely supported. However, tissue culture is expensive to set up on the small scale, and it's very equipment and skills intensive. You can be quite lucky with tissue culture as a beginner, but most people find that beyond a certain level, it takes a lot of practice and expertise. And if you're working on a small scale grow, you may find that it's better to take those requirements and use your resources elsewhere. Plant tissue culture is a frustrating process for cannabis. No one's got the one ring to rule them all media yet. If you're working in an ODC or New South Wales Ag compliant facility, the documentation's completely exhausting, extensive, takes up a lot of your time. As a small grower, there are lots of other methods and a few new ones coming in for small-scale disease-free propagation. Keeping a careful IPM strategy can allow you to maintain organic standards and avoid a lot of the pathogens, but there is a lot more monitoring these days than there was, say, 20 years ago. Cannabis plant tissue culture is largely experimental for a lot of endpoints, and success is extremely strain dependent. So our emphasis at Cymra is on a backup culture library, clean pipeline for plant house, uniform clones that perform identically and look identical for agricultural efficiency, IPM strategies, integrated plant pest management, that's the one. IPM strategies. We do monitor for accumulated generational mutations, and this is one of the sticking points for cannabis plant tissue culture. Multi-generation, as in conventional propagation, multi-generational tissue culture can increase the chances of unwanted mutations, and that work is underway in a lot of facilities worldwide. The other thing we do in the lab is we culture beneficial fungi. We found last year that some of the commercial products that we use for integrated pest management strategies were ineffective, giving us low spore counts, or were actually dead. And we've been hearing that for some time from other local growers who are using, and these are organic products. Some of them are quite established household names. One line that I heard complaints about was a trichoderma, which is pretty common and easy to grow, but it was full of slime mould, the commercial product. So we decided to start growing our own. And with 8 1-kilo bags, which is the size of a small autoclave or large pressure cooker, we can treat the entire facility once a week. And I think the cost for that in materials is about $4. So we've got 2 strains of beneficial mycoflora, 2 mechanisms of beneficial mycoflora. The first is the trichoderma, which is a minor growth stimulant. It's found in the environment. The strain we use isn't pathogenic, so it'll never become a weed risk. So we do have to reapply every week. And the other type that we employ, they're bug-eating fungi, if you've seen The Last of Us. If a spore from these land on a bug carapace, it will effectively explode the bug after it grows it out, which is super cool, but it means that Andy has a bugger of a time timing it with the release of the beneficial insects that we also use as part of the organic process in the plant houses. Tissue culture is a pretty dry subject. If you're looking for more information and you're an intermediate student or beyond, you can't do better than anything written by Max Jones or any of his colleagues in Canada. He's on LinkedIn and Google Scholar. Lots of his team's work is free to the public. He doesn't offer any complete solutions for the entire spectrum of in vitro cannabis work, but they've provided the best quality and accurate publications to date. It's a fabulous starting point for intermediate students. I'd like to acknowledge Nimbin MardiGrass org crew, Superbly Green, Cymra Life Science, boss Jamili out there, that's our boss, Jess, Simon and Joel, and especially the informal growers who started it all and continue the tradition. Thanks guys, over to Jess.
Hi, I'm Jess. I think Allison said before that we have been working together for 10 years, but Allison's actually been working in tissue culture for 30 years. So, you know, it's a lot longer than she said. I've worked with many species with Allison, and it was until the last year out of my own personal interest. So it's really cool to be working in it now. Deflasking is if you're never going to spend time in a tissue culture lab, but you're just a generalised plant nerd, you probably will have to deflask at some point because you'll buy some exotic plant online and it's the only way you'll be able to get it. So orchids come like this, just a bunch of things. I was looking at some really specific carnivorous plants that would come like this, and I'm going to take you through the protocol we use for cannabis, but this could be used for lots of species. So it's good to have genetics saved in culture, but how do we use them if something happens? We want to turn these spoilt, sugar-fed tiny babies back into photosynthesizing monsters whose stomates will open and close by themselves with all their normal natural defences. Our tech we love to refer to as Jamili Tech, again, our beautiful agronomist boss. why would we do it? So Allison's kind of covered why we would use tissue culture, but deflasking specifically would be to bring back lines lost to pests. The rejuvenalization of plants, so mothers get old and our stock gets older, and so starting from seed, they're not the same clones, so we can hit up the tissue culture lab and start again. Also back to the saving space. You can do this whole process sterile, but currently we aren't, and you don't need to. It is good, though, to keep your whole workspace clean when you do it. We want to start with healthy plants. So you know what a healthy plant looks like. They'll be green and lush and in active growth. We need empty containers. We use like takeaway containers, just the sort of smallish ones, and we put a couple of holes in the lids, which we cover with micropore tape, which is a good filter. Wearing gloves, keeping it clean again, wash your scissors. A couple of spray bottles, 70% alcohol, and a water one. And we use the Obturo plug, so a peat or cocoa little plug that we soak in a solution first, so like a water and feed, so a sea salt or a trikelp. And we don't want them to be too wet, just like not dripping but soaked. You've probably all done plant cuttings at some point too, so this is pretty much exactly the same, just on like a micro scale. So again, we want healthy little bits of plant, like maybe 4 to 5 centimetres, and we would cut off all the leaves. And apart from the little top two, they would probably do like half the leaves and cut off all the roots. We would dip in the rooting hormone we're using. We would press snugly into the plug and pop it into our little container, as many comfortably fit in the container. Before we shut it up, we spray the lid and then one little mist in the container, seal it, label it, and put it under normal, like can be natural light, but a greenhouse shelf. We have the lab, very lucky, so. It takes time. Containers will dry out, so we keep an eye on humidity and respray when needed. A few days in, we start to open the vessel. So we take a bit of the tape off one of the vents and repeat this a few days later. At 10 days, we crack the lid. This says remove any contaminated plants, but it really depends on the level of that contamination. Like if the plant is really suffering and you can tell it's not rooting, or if it's fully colonised by cobweb mould, get rid of it. Otherwise, it might be fine. Eventually, you will see visible roots on the outside of the plug, and this means they're ready to go. They can then go to the greenhouse where they're put in airproof pots, which is covered with soil. You want to make sure the top of the Obturo plug's covered in soil. Watered and fed, and then looked after like any other clone. So this is one of our little guys, and the possibilities. We could just make an army of them. Our results, we've had some good results. So with this particular protocol, it's 90% and above of tissue culture plants to happy, healthy growing plants. We've run some side-by-sides with normal clones and the ones we've bought out of tissue culture. And they've been great, especially the Super Lemon Haze. They were much bigger, healthier looking plants. It was really cool to see. We've got more science coming. We're looking at HPLC testing against regular clones, mutation accumulation and disease resistance. This is also an artwork I made for the plants in the lab, so they have a good idea of what theoretically we want them to look like. Thank you, MardiGrass. Thank you, Bunjalung Country. If you have any questions, let Allison and I know. Thank you.
Yeah, please put up your hand if you have a question and we'll bring a microphone over. No hardcore scientists here?
Hey guys, thanks for the talk. I was wondering if you guys could talk about your experience with endophytes and their roles in cannabis tissue culture.
They're naughty and they shouldn't be there. They get in the way. We actually haven't, because we're working on surface sterilisation, if we detect endophytes in a line that have to be, you mean beneficial endophytes or just contaminants in general?
Either. Yeah. Sorry,
okay.
Either, yeah.
Either? There's some that don't appear to have any negative effect. We throw them out anyway, out of the lab, because that requires further study, and it's better to work with sterile clones. Now, with the definitely pathogenic ones, it's been pretty interesting. As I said, we're really lucky to be able to do good science there. We were monitoring for hops latent viroid, and surprisingly found it in there. We were having issues with, when I first started, with one particular type of contamination. We solved those issues. It turned out to look like we had HLVD in other lines. We changed the sterilants. It appears to be gone. We're implementing on-site genetic testing very soon. We've done the workups. The testing's actually quite facile. We'll be able to do it large scale. So we will be able to monitor for any range of diseases, and I do believe that the sterilants are going to make the difference. We're currently running a side-by-side with 6. 12 months ago, we wouldn't have used most of those sterilants because we did believe that all of our plants were clean. Now it looks like some of them will have to be restarted and decontaminated. So even sterilisation, which we thought was a done deal, is everything's a variable and everything's an experiment.
Here we have another question here.
Thank you, that was great. So when you were talking about your generational mutation load of accumulation, how do you screen for that?
Morphologically. Not yet. Kane, who's sitting next to you, did some work in 2020, I think it was, looking at the validity of a publication that I don't even remember what it demonstrated, but it was something like, this is the way, this paper is valid, that says this marker is the one to watch for deleterious mutations, not just minor mutations that don't make any difference to the agronomy or the growth, but actual mutations you don't want. Now that was 5 years ago. So people are looking at markers and there's publications out there, but we need to repeat that work, 1, to make sure it works, 2, to make sure it works in the Australian environment. And it's very much a worldwide phenomenon that kind of monitoring is ongoing. We have to be careful of pathologising stuff. There's a lot of cannabis testing companies out there, especially in the US, who are offering services for not just hops latent viroid, but a bunch of things that they're new and they sound scary. Maybe, as you said, Leonard, they're endemic to the plant itself and they don't cause any harm, but they can bill you $35 a test. We need to prove that if there's something in the plant, it's actually damaging before we start screening for it. Does that make sense?
Yes, because I imagine if you're not doing actual sequencing, there could be a lot of cases, and I don't know because I'm not a tissue culture expert, but there could be cases when you keep going through tissue culture that you get kind of like a physical adaptation, a genetic adaptation to things rather than actual mutation.
Yeah, absolutely. Hormone habituation is a known issue. where it's like they just get used to it and you don't know until you put them out in the field that they're a problem. We haven't found this in our cannabis work, but it's well known that for plants there are hormones like benzoylaminopurine, which is one that encourages side branching, and if you put a BAP plant out in the field, after a few generations, there's a pretty damn good chance it's just going to stay stunted. We don't want that. One of the ways we avoid that is by working with metabolic pathways rather than the formal hormones. And the only hormone that we're currently using is one that most growers use as a rooting hormone when they're striking normal cuttings anyway.
We have another question over here. No? No. Okay. Anyone else before we wrap it up? Okay, look, thank you so much for coming and sharing such expert knowledge. Like, MardiGrass is pretty damn, special to have had your time today. Thank you so much. And yeah, thank you to Cymra Life Sciences for coming. And
Superbly Green.
Yeah, and Superbly Green, which is a beautiful name. For coming and sharing what's going on in the regulated industry and, some really important science around creating those amazing organic plants.
Thanks,
Lovely.
Kat.
Thank you.